law. What the ideal gas law is the gas law that allows us to introduce moles into the gases equation. So it allows us to come up with a certain quantity, or allows us to change the quantity of a gas within a system. So far we haven't really been doing anything with what happens if I add more gas or take away more gas. So this will allow us to do that. So the equation for the ideal gas law is PV equals nRT. So PIV-NERT is kind of what it's called, PIV-NERT, where P and V are pressure and volume, N, that's a new variable for us, N is the moles, R is the gas constant, which we'll talk about here in a second, and then T is temperature. Remember, temperature still has to be in Kelvin, volume needs to be in liters. Now, what about this gas constant? Well, there's three values for the gas constant. And they are, R will either equal 0.0821, 8.31, or 62.3. Now, how do you know which one to use? Well, it's based on your unit for pressure. Remember we talked about last week, and we did conversions last week with pressure, how it can be in bunch of different units. Well, if pressure is in atmospheres, ATM, then you're going to use 0.0821. If pressure is in kPa, you're going to use 8.31. And if it is in millimeters of mercury or torr, you're going to use 62.3. So you need to look at the unit for pressure, and that will determine what your value for R is going to be. Okay, which one of those three? All right, so let's do a couple examples. So here's the first example. A certain gas is placed in a 3-liter container at 55 degrees Celsius. The pressure is measured to be 0.0821 atmospheres. How many moles of gas are present? So, I'm going to change this not to 0.0821. I'm going to say 2.0 atmospheres. Okay. 2.0 atmospheres, how many moles of gas are present? So the question is asking us for moles, so we're solving for N. So my pressure is 2 atmospheres. My volume is 3 liters, so P times V equals N, that's my unknown, that's what I'm trying to solve for. R, since our pressure is in atmospheres, we're going to use the 0.0821. 0.0821, and then my temperature is 55 Celsius, which is equal to 328 Kelvin. So add 273, you get 328 Kelvin. So now I'm trying to solve for N. So I'm basically going to take these two numbers and divide both sides by those two numbers. Because then these cancel. And then if I do that, so 2 times 3, which I know is 6. So I'm still going to put it in here anyways, divided by 0.0821. I'm putting them in parentheses so that we can times 328, and my moles are 0.22 moles. So that's my answer. Okay. Now, let's do one more. So here we have 7.5 moles of gas are placed in a 10-liter container at a temperature of 100 Celsius. What is the pressure of this system? So the question is asking me for pressure this time. So P is my unknown. volume is 10 liters, N is moles, which is 7.5. Now, what R value I'm going to use, it really doesn't matter, ultimately, unless it tells you a specific unit that you need your pressure in. But since we used ATM in the last one, let's do kPa. So 8.31. So then we know our answer will be in kPa. And then temperature is 100 Celsius, which we add 273, so we get 373. So now what we're going to do, we want to get P by itself, so we're going to divide this whole thing by 10. Those cancel, and P equals whatever that is going to, so 7.5 times 8.31 times 373 and divided by 10. So it's 2325. Let's call it 2325. So 2,325 kPa. I know it's kPa because that's the R value that we used, was the one for kPa. Okay. All right. I hope this helps. Let me know if you have any questions.